Okay, in this video, we will go over Charles' law and go over two example problems. So Charles' law, the formula is initial volume divided by initial absolute temperature, so it must be in Kelvin, is equal to final volume divided by final absolute temperature, likewise in Kelvin. And so we have two problems. First problem is this: 750 centimeter cubed of fluorine at 45 degrees Celsius will occupy what volume at 65 degrees Celsius? And so from this equation, there is a relationship between volume and temperature. And so let's just solve this problem. So in our situation, the initial volume is 750 and the initial temperature is 45. Now 45 you need to convert to Kelvin, and we know the final temperature 65 Celsius convert to Kelvin, so we're just missing our final volume. And so let's rearrange what we have. So we know volume of initial as 750 centimeter cubed. This will be divided by our initial absolute temperature in Kelvin. And so to convert from Celsius to Kelvin, it's pretty simple. It's 45 Celsius, what we have, plus, it's a constant, always 273.15. So this right here will be in Kelvin. And if you use a calculator, you will get 318.15. And this will be in Kelvin. So K. So this goes right here, 318.15 in K, Kelvin, is equal to. So we're trying to find the volume, but we know the final temperature as 65 degrees Celsius, which we need to convert to Kelvin. I'll just do it directly here. I'll say 65 plus 273.15, and we can call this as K, Kelvin. We want to solve for VF. So this is what we're trying to solve for. And now we just need to rearrange a little bit to ultimately solve for VF in centimeter cubed. So VF is equal to this piece right here, 750 divided by 318.15. We can put our units, centimeter cubed and Kelvin, multiply by this piece right here. So times 65 plus 273.15, and this is in Kelvin. Now let's check our units just to see, does this make sense? So K cancels, and we're just left off with centimeter cubed. Volume, right? So that is correct. So now if we use a calculator, and if we multiply everything out, we would get 797.15 centimeter cubed. This right here is the final volume. And now we'll do the second problem. A container holds 60 millimeters of oxygen at 25 degrees Celsius. We want to find the temperature in Celsius if the volume is increased to 90 mil. So in this case, we're trying to find the final temperature in Celsius. So let's do this. This problem involves another step because we need to convert from Kelvin back to Celsius. And I'll show you what I mean. So I just brought the problem down over here so we have more space. So we know that the initial volume is 60 mils. And actually, let me rewrite the equation first. So the initial, T initial, and so this is equal to our V final over our temperature final. So in this problem, our V initial is 60 mils, and our temperature initial is 25 degrees Celsius, which we know we need to convert to absolute temperature, so we need to convert to Kelvin. So we get 25 plus 273.15, and this right here is in Kelvins, is equal to. So in this case, we know the volume of the final, but we don't know temperature. So we know volume of final as 90 mils, and this is going to be divided by T final. So it says we want temperature in Celsius, so we need to ultimately convert. So let's try to calculate TF in Kelvin first, and from Kelvin we would go to Celsius. So we can say that 60 TF is equal to 90 times this. So 90 times 25 plus 273.15. Divide by 60, divide by 60. So TF is equal to 447.23 Kelvin. And let's just check to see that this makes sense. So this is milliliters, this is Kelvin, this is milliliters, so this should be Kelvin. So it does make sense. Now we need to convert to Celsius. So going from Celsius to Kelvin, you add 273.15. But going from Kelvin to Celsius, you would subtract 273.15. So minus 273.15. And this right here will equal approximately 174.1 degrees Celsius. And this right here is our final answer to our problem.